As in the last episode, we'll be putting Joe through 3 different thought experiments, resizing people, stars, and starting with our very own planet. So here goes. Earth is the 5th largest planet in our solar system. And it's also, of course, the 4th smallest. 12,756 kilometers across, with an atmosphere 100 kilometers deep all the way around. Below that is the surface, a thin layer of solid rock, sitting on top of 5,000 kilometers of rock and molten metal. And finally, at the core, a 2,400 kilometer wide ball of solid iron. The question is, how much do those numbers really matter? How important is it to our lives on Earth that our world is exactly the size it is? What would happen if we halved its width? Meaning that instead of being a shade bigger than Venus, Earth was suddenly a shade smaller than Mars. Well, there's only one way to find out. And there it is, a half-sized Earth, all made of the same stuff, same proportions, just a little bit smaller. Well, as it turns out, Earth's vital statistics are, well, vital, because changing Earth's size messes with a few other things that you don't necessarily want to be messing with. For instance, gravity. As we discovered when we made things big, the gravity of a planet is in proportion to its width. So, a half-sized planet would mean half the normal gravity of the surface. Enough of a change to put a spring in your step. And if you're athletic, like Joe here, who knows what you might be capable of? So, half gravity would mean you can jump higher and only fall at half the speed, which would take a little bit of getting used to, but by and large, sounds rather fun. So, you might ask, what's the catch? Joe's fun wouldn't last long.
The universe is a system, basically. So size is important in the sense that if you change the size of one single element with respect to the others, then the whole thing breaks.
You see, gravity doesn't just affect people and objects. It also affects the air we breathe, which would get thinner because it would be less strongly attracted to the ground. The air at sea level would now be as thin as it used to be 2/3 of the way up Everest. There would be less oxygen in every breath. Headaches, nausea, and shortness of breath would soon follow, as Joe found himself with a nasty case of altitude sickness. Luckily for him, humans can acclimatise to thinner air. After a few days, Joe's red blood cell count would increase enough to compensate for the reduced oxygen. So he'd be back up and about in the low gravity of a half-sized Earth, just in time to notice that it's beginning to look a lot like Norway. The spectacular phenomenon that is the aurora isn't usually seen beyond the polar regions, but our new